All right, guys, the next type of graphs we're going to cover are called cardioids. Cardioids look like hearts. You have R equals, the general form for these are R equals either A plus A sine theta. Actually, A plus minus. You can have a little minus there. Or R equals A plus minus A cosine theta. So if you had to guess the type of symmetry for the sine equations, what would you guess? Excellent. Symmetry with respect to vertical axis. And if it's cosine, you can have symmetry with respect to the horizontal axis. But what about the plus and the minus? So the plus means something, and the minus means something else. So let's try an example to see if we can come up with those meanings. Okay, so example 1. Let's try 2. So R equals 2 sine of theta plus 2. That's the same thing as 2 plus 2 sine theta. So right away I recognize it's a cardioid because these two values are the same. Okay. So if I were you, I would start with a helper graph. I remember that graphing 2 sine theta plus 2 means my A value, my max is 2, my minimum is negative 2, but the whole graph is shifting up 2 units, so I'm actually going from 0 to 4. And there's no change in period or frequency. So we're good there. There's no B value, no C value, no phase shift, anything like that. And these won't have anything like that. We just remember that, you had your amplitude, but do consider your shift, your vertical shift. Okay, so then my graph starts at the max. No, starts at the equilibrium. Remember, sine starts at whenever the equilibrium is. Then goes to the max, then minimum, then equilibrium. Wait, no. Max, equilibrium, minimum, equilibrium. There we go. So it's just a pattern that we're following here. Okay, so that's one period of this graph in the rectangular plane. But I'm going to use that to help me out with my polar curve. All right, so I'm going to need at least 4 rings. And I'm going to start with the angles. So at 0, I'm at 2. So when theta equals 0, R is 2. Theta equals 0, R is 2. Then I'm going to go to pi over 2, 4. So when it's pi over 2, I'm going to count four rings. 1, 2, 3, 4. Then the next point is pi 2. So I'm going to go to pi and then count 2. And then at 3 pi over 2, I'm at 0. At 2 pi, I go back to 2. Okay, so you see these 1, 2, 3 dots here. What does my general graph look like? Well, in between the points, between 0 and pi over 2, R is increasing. So between 2 and 4, between 0 and pi over 2, it's increasing. Okay. Between pi over 2 and pi, then it starts to decrease. Between pi and 3 pi over 2, it's also decreasing. And between 3 pi over 2 and 2 pi starts to increase. So this is what we call the shape, this is what we call a cardioid. Okay, where the length between, or the distance between the pole, the origin, and the point that's most furthest out, that's twice your A value. And the plus here means that this cusp here is pointing up. Okay. So when you see a graph that looks like A plus A sine theta, you're going to have a vertical distance between the pole and the point that's most furthest out, and that's 2A. And then the plus means that the cusp is pointing up. Okay. So if you had a minus, let's play around with this. So let's go to decimals. What if you had a minus? What would that look like? Well, then you have R equals, let's try 2 minus 2 sine theta. There, you see that it's pointing down. Your distance is still between 0 and the point that's most furthest out. That's still 4. But now the heart, if you will, has a cusp that's facing down. Okay. Now, what if you had a cosine? Then you have R equals, let's say, let's try something bigger. Let's say 3 plus 3 cosine theta. So now the cusp is pointing to the right. You do have symmetry with respect to the horizontal axis. And the distance between the point that's at the pole and the point that's the most furthest out is twice your A value. So it's 6 here. Okay, so let's go back to our summary then. Plus, if it's a sine graph, means the graph is pointing, the cusp is pointing up. If it's minus, the cusp is pointing down. If it's a plus and it's a cosine, that means your cusp is pointing to the right. If it's a minus, means the cusp is pointing left. So if you want to draw a little one here, if it's a plus, it's pointing up. If it's a minus, it's pointing down. And they're cardioids. They're kind of like hearts. And then, so if it's a cosine, if it's pointing to the right, it looks like that. And if it's pointing to the left, it looks like that. And the distance between the point that's at the pole and the point that's furthest out, that's twice A. Okay, so these again are cardioids.